Okay, so today we are going to continue our exploration of simplifying radical expressions. Today we're going to do rationalizing the denominator. This is the back of the worksheet that we've done before. Some of you might have this in your notebook already. This is the front of the worksheet, and we have another video that described that. So this is the second video to do the back of the worksheet. So, rationalizing the denominator. First of all, there's a general rule that says when you have a fraction that involves square roots or radicals, we don't want to keep our final answer with a radical sign anywhere in the denominator. So all of these that you see here have radicals in the denominator, and we need a way to rewrite this expression in a way that it doesn't change the value of the expression, but we have to get rid of that radical in the denominator. So the basic rule here is we're just going to multiply the numerator and the denominator by whatever is under the radical in the bottom of your fraction. So, in this first one, there's a square root of 3 on the bottom. What we want to do is multiply that by itself. Square root of 3 times the square root of 3. Because multiplying it by itself makes it become that number without a radical sign. So, let's talk about why that works. If you have the square root of 3 times the square root of 3, another way to think about that is the square root of 3 squared, right? Because when you multiply something by itself, you're squaring it. This symbol, square root, and this squaring are inverse operations of each other. They kind of cancel each other out. Just like if you add 7 and subtract 7, it cancels each other out. It's like nothing ever happened, right? So this is like taking the square root and then squaring. It cancels everything out and you're left with just 3. Another way you can think about this is that the square root of 3 times the square root of 3 equals the square root of 9, right? Because 3 times 3 is 9. Well, the square root of 9 we know is 3. So no matter how you look at it, when you square or multiply a radical by itself, it ends up being that whole number without the radical sign. So we've accomplished making our denominator not have the radical. Well, you can't just multiply something on the bottom of a fraction without doing the same exact thing to the top of the fraction. Because essentially, if we multiply the top and bottom by the same thing, you're multiplying your fraction by a value of 1 whole. Right? The square root of 3 over the square root of 3, anything over itself, equals 1 whole. So we're just multiplying by 1, and we know multiplying by 1 does not change the value of anything. So it's okay to do. So whatever you do to the bottom, you have to do the top. On the bottom, we have plain old 3. On the top, we have the square root of 5 times the square root of 3, which, as we learned in the other video, is the square root of 15. You can just multiply what's under the radicals, keep it under a radical sign. So our final answer there is the square root of 15 over 3. All right, let's look at the next one. Here we have a fraction under 1 radical sign. Well, one of the properties of radicals is when you see a fraction under the radical sign, you can think of it as the numerator and the denominator having separate radical signs. So square root of 5 halves is the same thing as the square root of 5 over the square root of 2. That's just rewritten. Now we want to rationalize the denominator. Remember, we're going to multiply the top and bottom by whatever the radical is in the denominator. So we're going to multiply the top and bottom by the square root of 2. Multiply square root of 2 on the bottom, multiply square root of 2 on the top. Again, on the bottom, square root of 2 times the square root of 2 is just 2. And on the top, the square root of 5 times the square root of 2 is the square root of 10. So that's our final answer. Number 9 is a little tricky because this one is actually not simplified yet. The square root of 12 can be simplified further. So we'll get the same answer whether we rationalize first or simplify first, but I tend to want to simplify first. Okay? So let's take the square root of 12. Like we learned on the other video, this can be rewritten as the square root of 4 times the square root of 3. That's 12. Square root of 12 equals the square root of 4 times the square root of 3. And on the bottom, we also have this whole number 3. So our denominator, when we simplify it, the square root of 4, we know is the whole number 2. Got our 3 out front. We got radical 3. So our denominator becomes 6 radical 3 with the 8 on top. So this is just simplifying the denominator. We haven't rationalized anything yet. Now I want to simplify even more because I've got an 8 on the top and a 6 on the bottom, and both of those can be divided by 2. So I'm going to make this 4 over 3 root 3. So always simplify first. Well, that's great. We have 4 over 3 root 3 now, right? But we have to rationalize the denominator because we can't leave it with a root 3 on the bottom. So again, we're going to multiply the top and bottom by whatever's under the radical in the denominator. So we're just going to multiply top and bottom by root 3. On the top, we get 4 root 3. We can't multiply the 4 and the 3 this time because the 4 is outside of the radical sign and the 3 is under the radical sign. So these are not able to be multiplied to make 12 or something. This has to stay 4 on the outside and radical 3, the 3 is underneath the radical. On the bottom we have 3, that's this 3 out front, and then these two, radical 3 times radical 3, is just 3 again. So this one becomes, final answer, 4 root 3 over 9. That one had a lot more steps to it. Okay, number 10. This one's a little more straightforward. What do we multiply the top and bottom by? Hopefully you said square root of 7. On the bottom we get just plain old 7. On the top we get the square root of 77. That's your final answer. For this one, kind of like the one above it, we can rewrite it as the square root of 7 over the square root of 8. But this time the square root of 8 can be simplified. We want to simplify that first. Square root of 8 becomes square root of 4 times the square root of 2, which is just 2 root 2. So simplified, we have the square root of 7 over 2 root 2. Now we need to rationalize the denominator because we can't leave our answer like that. We have to rationalize. So let me rewrite it here. Multiply top and bottom by whatever is in the denominator, whatever's under the radical in the denominator. So on the top we're going to get the square root of 14, and on the bottom we have 2 times, and again that's this 2 on the outside, then we have radical 2 times radical 2 is just 2 in itself, so we get root 14 over 4. That's your final answer. All right, this one got kind of squeezed under here. Again, we have a radical in the denominator that can be simplified. Square root of 20 is the square root of 4 times the square root of 5, which is 2 root 5. And we still have this 5 from out front. So if we rewrite this fraction, we're going to have the 6 on the top and 10 root 5 on the bottom. That's rewritten. Now we have to rationalize our denominator. 6 over 10 root 5, multiply top and bottom by root 5, and you get 6 root 5 over 10 times 5, right? These two radicals are just 5, and then we got our 10 out front. So that becomes 6 root 5 over 50. And again, radicals work a little bit like variables, where, like if I had 6x over 50, I could simplify the 6 and the 50 and leave the x alone, right? So the same thing here. We're going to leave the square root of 5 alone, but I could simplify the 6 over 50 because both can be divided by 2, and we'll get 3 over 25. So 3 root 5 over 25 would be your final answer. Okay, now some of these practices might be the same as the other practice worksheet that you've done, but this is a combination of both things: simplifying the radicals, plain old simplifying radicals like you had in the other video, and there's a few where you need to rationalize the denominator. Actually, none of these have a rationalizing the denominator one. So we'll have to do more practice in class. Okay, thanks.